So let's take an example. Let me call it example 4. You're asked to evaluate. You're asked to evaluate the integral. Sorry, just a minute. Okay. You're asked to evaluate the integral ranging from the bounds are 1 to 2, 2x plus 1, natural logarithm x dx. So which one do you think we can pick first? So from the expression I wrote here, I think I will choose first, since there is no inverse trigonometry, then I will choose first the logarithm. So that means my solution will be my u, to make my u my natural logarithm x, right? So which means that we are on the right track. And so that means then I'll make my dv, don't forget your dv, I'll make my dv to be what? 2x plus 1 the what? Dx, right? My dv. Is that right? Yes. So then I differentiate because I need this, from the formula in equation star star up here. So I have this to be what? 1 over x dx. And I have my v. So if I integrate this, integration, right? Which is xn dx. So if you have this will be what? Xn plus 1 over n plus 1, right? So plus c in any way. But here you don't need a c here. So if I integrate this one using this formula, I have this to be x squared plus x. Is it right? So using the formula star star, I can obtain that my integral of 1 to 2, of 2x plus 1 ln x dx is equal to, now your uv is simply x squared, I can use the red pen, x squared plus x, right? And your natural logarithm, right? So minus, now you need your vdu, which is simply so this means I can write this as, now if you solve this, you get x squared over 2 plus x into bracket, then you need your 1 and what? And 2. Now if you might ask, how did we obtain this? Now this is your u dv, right? So, and v du should simply be, v du is x squared, integral of 1 to 2 of x squared plus x, right? The u is what? Dot 1 over x dx. And this is simply integral of 1 to, then this is simply x plus 1, right? Dx. And if you integrate this, you should get x squared plus 2 plus x. You understand? So this is how we obtain what we have inside of here. Yes, what we have inside of here. So if you solve this accordingly and you substitute your value using your fundamental theorem of calculus, yes, so you will obtain that. Okay, so I have x squared plus x, right? Let me use negative x squared over 2 minus x, 1 and 2. So if you substitute, you have 2 squared, right, plus 2, natural logarithm of 2 minus 2 squared over 2 minus 2, right, minus what? 1 squared plus 1 natural logarithm of 1 minus 1 over 2 minus 1, right? So if you substitute and you, so this will give you 6 of 6 ln 2. This is 4, so that is minus 2, so this is minus 4. This is 0, right? So you don't need anything to do with that. And natural logarithm ln 1 oh, minus 4, yes. So this is 0, right? So this is plus 1 over 2 plus 1, right? And this will give you the final answer to be 6 ln 2 minus 5 over what? Over 2. So this is your final answer. And finally, let's take an example. Let's call it example 5 of evaluate the integral of the integral of 0 to 1 arc inverse of x dx. So just like what we said, so I will leave this for you as an example, an exercise. So your u is simply arc inverse of x, right? And so that means your dv will simply be what? Dx. And your du will be what? If you differentiate this, you should get 1 plus x squared dx, right? And your v should give you what? Should give you x. So I want you to do this example, and your final answer should give you, let me write it out here. Final answer is pi over 4 minus 1 over 2 natural logarithm of 2. So this will be your final answer. Yeah.